Hi everyone, this is Mr. Cardoso, and this is our next lesson in our video series on the introduction to objects. In this video, we're going to talk about hiding information. And before we get to who we're hiding the information from, let's review who's writing what. So back over here, let's go back to our fraction example. So we've created this fraction class. So let's say, for example, that's call it the primary programmer who created the fraction class, and it's our cookie cutter for one single fraction. This is what defines what a fraction is, a numerator and a denominator, or what it consists of. We think of those as the nouns. And then, we've got our methods down here as well as our constructors that tell us what the object or what a single fraction can do. So a single fraction can create itself. That's what the constructors can do, and print itself out and multiply by another fraction, add to another fraction, and so on. Reduce, which is down there, right? So this is what the cookie cutter class for the fraction, and every time we add a method to this, it further gives a functionality to what that fraction can do. Now, when we go over here to the fraction calculator class, this is kind of like us just testing out our fraction. So we can create some fractions using our constructors, we can add them together, multiply them out, make sure everything works. Usually, the person writing this class is a secondary programmer. It's not necessarily the same programmer as the person writing this class. So, for example, let's say you work for a company. You might write the fraction class, and let's say everybody on the 21st floor might use that fraction class for various different programs. One might be making a fraction calculator, one might be doing a whole other program but needs a couple of fractions in there here and there. One might be doing a calculus program, but there might be some fractions involved, so they have to make some fractions in it. So a whole bunch of different people on the 21st floor might be using the fraction class for different reasons and different purposes in their own programs for the end user with their own purpose. So that's who we kind of want to hide information from. We want to protect information from those 21st floor programmers in this example, because things might go bad. So what could go bad? What could go wrong? What could really go wrong with a fraction? One of the things that could really go wrong in a fraction is, for example, having 0 in the denominator. Nobody likes having 0 in the denominator. But let's say, for example, one of the programmers on the 21st floor, they didn't, put 0 in the denominator. So, for example, I can go over here and put 0 in the denominator of f2, and you're like, well, if these people all on the 21st floor, they're not, going to put 0 as the denominator, so, that's never going to happen. And they might not. But remember, you could also read this in from the user. Like in one of their programs, they might be asking the user to enter the numerator and the denominator, so they might do something like, scanner or KV reader or whatever, dot next int, right? And they might grab that information from the user, and that might be a 0 from the user. Or somehow you calculate it. Maybe you forgot to, hopefully you remember when you, let's say we did 1 divided by 2 over here in the interactions panel. What's the answer to that? It's 0 because of integer division, right? We know it's 0.5, but because these are both integers, we get a 0. So something like that might happen in that kind of error, and you might end up with 0 in the denominator. And so we want to prevent this kind of thing from happening. So how do we do that? Well, what we do is, so for example, if I put a 0 here, let's just show you right now. If I put a 0 here, let's compile this. And this is just a warning that's saying we never actually used, f2. See, we printed out f1. So let's print out f1, and we get 1 over 2. It works just fine. Let's print out f2. Compile that and run again. And we get 1 over 0. So that's not good, right? And why not 3 over 0? That probably has something to do with either our reduce method. So in our reduce method, we reduced it, right? And so 3 over 0 got reduced to 1 over 0. But nonetheless, that's still not good because we have a 0 in the denominator. And so that could lead to other mathematical issues down the road. So let's say we want to prevent that from happening. So what we're going to do is, whoever's writing the fraction class, what we can do is we can come in here and try to change one of our constructors. So here we're taking our numerator and our denominator right here, right? This is the one we're using here. Right now we can, because this is just like any other method, any code that you can use in a normal method can work here. So whether you're talking about if statements, while loops, for loops, any kind of thing like that can still be used within these two brackets. So let's go ahead and do that in here. So what we're going to do is we're going to say if d is 0. So if they're trying to send us in a value of 0 in that second field for the denominator, then maybe we send a message back and we say system.out.println, hey, you can't do that. And otherwise, we will set it. Right? So now what happens? Well, let's take a look. So let's compile that. Let's go back and run it. So here we actually tried to send a 0 in there. So let's run this program. It says, hey, you can't do that. And then we print out F2, and it's still saying 1 over 0, which is the reduced form of 3 over 0. So it's still doing it even though we sent the message, hey, you can't do that. So that's not good. Well, the reason why it's still doing it is because if the denominator is 0, we just send a message. That's all we do. And then we don't do anything else, which means that the denominator has to have its default value, and its default value for an integer is 0. So instead of just doing that, let's come back over here. Let's make it so we can do a multiple line here in this if statement. So we'll say you can't do that, and we'll set d to 1. Okay, so now it has a value no matter what. So if it's 0, we'll set it to 1. And maybe we want to communicate that to the secondary programmer on the 21st floor. Denominator set to 1. Okay, so let's compile that now. Go back over here, hit the run button. Now it says, hey, you can't do that. Denominator set to 1. And then when we print F2, we're still getting 1 over 0. So let's take a look at why that's happening. It could be in our reduce method. No, our reduce method is not being called. So if the denominator is equal to 0, oh, we set this denominator to 0. So it's good that we found that problem. That's a common mistake. We're actually talking about the denominator that the user sent us in the parameter. We set that to 1. If that's no good, we have to set this dot d to 1. So this, or this dot den, actually, we should say. That was the issue. Hopefully you caught that the first time I did that. So that's good. So now we can fix that. Go back to the fraction calculator, hit run here. And now we get 3 over 1. So the user tried to send 3 over 0, and that 3 over 0 got translated into 3 over 1 with a, hey, you can't do that, denominator set to 1. So anytime you try to do that, right, now we're going to get 2 of those messages. Hey, you can't do that, denominator set to 1. We just printed out the first one. So the second one. Let's print out the first one here. And now you get 1 over 1 and 3 over 1 instead of 1 over 0 and 3 over 0. Okay, so now that's working. But you could say, well, sir, now we're in this, the 21st floor programmer could still hack this and could still set it to 0. How did they do that? Well, you can find a loophole. So you can go f1.den set to 0, right? Because they still have access to those fields. So if we do that, now, guess what? it goes back to 1. So in the constructor, which we've done for F1, we've checked that, make sure that this is not 0. And it did, it set it to 1, but then immediately after, the secondary programmer, or the user programmer, set it back to 0 by accessing the field directly. And again, like I said, this could not be a direct set. This could be coming from the user using the scanner or something like that, right? Or due to some calculation like 1/2, which would result in a 0. So it could happen, is what we're saying, and that's not good. So we want to stop them from being able to do this, right? So how do we do that? Well, that's where we come back to hiding information. So we're going to go back into this class now, and here notice we don't have a public or a private in front of it. So what I'm going to do is I'm going to put private in front of the den. What the private means is that this den can only be accessed within the confines of this class. So the open and closed curly brackets. So it can only be accessed in there. So when we go over here and we try to do this, it's not going to let us do it. It's not even going to compile. We're actually going to get an error. This is an error, not a warning. It says the field fraction.den is not visible. It's not even saying that you can't access it. It's lying to you, really. It's just saying it's not there or it's not visible, right? So you can't, the secondary programmer now on the 21st floor cannot change this field directly. What if they wanted to change the numerator? Right? The numerator is fine. There's no restrictions on the numerator. The numerator can be any real number, or in this case, any integer. So that's the restriction because that's the data type. But it can be anything. So there's no error with this line. If I change this, and it doesn't matter if it's 0 or if it's 3 or whatever number, it's not going to let me do it. It's not going to let me change that value because it's saying you can't even access this field to change it in the first place. Well, how then do we change the denominator if we want to? Is the only way to change it in the constructor? No, there's another way to change the denominator field. So we do that with what we call a setter method. So a setter method allows you to set a value of a private field. So setter method, otherwise known as AKA mutator method. If you want to change the value, mutator, I can't spell, mutator method, which allows you to change the value of a field. So let's see how we do that. So after our constructors, it basically becomes an instance method. So we'll make the method public because in the method we can put if statements. So we'll say public. Now what do we want to return? Nothing, because we are going to take a value and change it. And we call this set den. We usually call setter methods set and then whatever the field is we want to set. So in this case it's the den field and in camelback format. And then we take in the new denominator that we want to set. So let's call that D. And in here you say this dot den gets D. Now, if the user wants to change it again, they can't change it like doing this. They can do that with the num. But here we've got to go set den. And here you put the value inside the brackets, like that. Now again, it's not returning anything. It's a void method, so I don't have to put anything on the left-hand side. So I'll do that. And so now it lets me, it works, and it set the denominator to 3, as you can see down here. But what's the problem then, sir? We're back to square one. If I put a 0 in there, that's going to work just the same, and we get back to 1/0. So what we can do here, because it's a method, like we said, in this setter method, we can put the same sort of if statement that we have here. In fact, I'm going to copy and paste this. And I'm going to say if d is equal to 0, hey, you can't do that. Denominator, instead of setting it to 1 because it's not a constructor this time, we'll say remains unchanged. And so basically we won't do anything to the denominator, and otherwise we will set it. So now we can come back here, and if we compile that and hit the run button, it says, hey, you can't do that, denominator remains unchanged, and